I'm going to go through the rest of the Excel spreadsheet now, illustrating what we did in section 4 of topic 6, where we looked at lots of equity risk factors and FX risk factors. And the spreadsheet is still fairly simple. I've got like 2 equity and 1 FX, but the concepts are illustrated with that set up already, so it's complex enough, I think. Okay, so this is where we are with the example here. Which example is it? It's this one here on slide 38. So we did this solution by hand. It's a systematic bar with 1 equity and 1 FX risk factor. And here is the result. Okay, so we've got 2 million here. We can change this. We can't change the FX exposure. That will change automatically. See, this equals B2. Let me just bring it up a little bit so you can see it slightly better. Okay, so that is set equal to that. That's why it's blue. You can change everything else like the holding period and so forth. You can change the betas as well. Actually, this should be blue as well. Don't change that because, as I said, it's always 1. There we are. That's blue now. I'll save it later. Okay, so we have a US investor has $3 million to invest in a FTSE portfolio, not the FTSE itself, but a FTSE portfolio, because the beta is not 1, it's 1.5. That's the percentage beta. And the FTSE 100 index, if you just download data and look at the returns, you can calculate its volatility or standard deviation. Here we've just given risk factor volatilities, which you can change, and a correlation here. All these can be measured on historical data. And if you measure them on daily data, correlation is independent of any unit, but the risk factor volatility would be, if it's daily data, you'd have to use the square root of 250 to get that as a volatility. Okay, so now the covariance matrix here is an annual covariance matrix. I've just taken the volatility and squared things. Similarly, for the covariance between the 2 risk factors, I've just taken volatilities. It's different to the way I did this one, where I did a 1-day covariance matrix and divided each entry by 250. Every element is divided by 250 to make it into a 1-day covariance matrix, which means that then when it comes to the VAR calculation, you see here, that's the M mult, but the equity VAR has got the square root of 10 coming in at the very end there. Okay, there are so many different ways to do this. In this case, I got the dollar betas and I got VAR directly in dollars. In this case, I'm going to use the percentage betas. Okay, so the VAR will have to be changed into dollars, which is what this column does here. But, you know, there isn't just one ordering. There's not just, your sequence of steps can be, as I said before, with the covariance matrix. You can make that 1 day and then scale up, or you can have an annual one and then do a different type of scaling. For example, here I've got the M mult, the beta prime VB for the portfolio variance, and that's an annual variance. And then to convert a variance to H days, I've got to not use the square root because it's variance, but multiply by the holding period divided by 250. Okay, so once we've got the H-day variance, we're going to use the normal model, norms in 1 minus alpha times the square root of the H-day variance. That gives the systematic VAR. And then for the equity VAR, I'm ignoring the correlation. I'm just using 1% in 10 days, but it's beta times the appropriate standard deviation there. So I've scaled here. So divide the volatility by square root of 250, but also multiplied by the square root of 10, and the square root of 10 over 250 is the square root of 1 over 25. So this number is actually 5, which it appears as in the slides. And I do the same for the fx var, and then I can sum the vars in percentage form and see that they are bigger than the systematic var here. And likewise, I can use the 3 million number here and multiply everything by 3 million to get the fx var and the total var. Okay, so now what happens if we have two? It's this last one. I've got two portfolios and one exchange rate risk factor. And these are the numbers that I gave on the slide, which for so many, I made them red so you can see. But we can change these. If you change the red bit, so for example, if you change that to say 0.7, then F2 will also change because it's symmetric. The correlation matrix now is correlation between the second row and first column is the same as the correlation between the second column and the first row. Anyway, in the question we have these figures. I think that was 0.8. And so how am I going to do this one? As I said, okay, so I've got an H-day covariance matrix. I didn't do annual, didn't do once, I made it H-day. Okay, the third way of doing it. So how do I make it H-day? Well, I take the volatilities, but then I'm going to use 10 over 250. Don't forget, you don't have the square roots in the covariance matrix. So every element of the covariance matrix is multiplied by, in this case, 10 over 250, or more generally, whatever is in B6 over 250, assuming 250 days a year. That one's just symmetric. So what's this one? Well, this one is the covariance between the two equities. And this one is the covariance between the S&P and the exchange rate. And this one is the variance of the FTSE part. And this one is the variance of the FX part. And this one is the covariance between the FTSE and the exchange rate. And now I've got my betas in dollar terms here. So this beta is 2 times whatever the value is here. This is 1.5 times whatever the value is here. And this one is a product of those two. But it's always the nominal amount invested in that currency because the beta is 1. And then this is equal to the foreign exposure. All right, so I'm going directly in dollar terms here because that's what it asked for in the questions instead of doing first percentages. You can always do it in dollars first and then convert to percentage because there's that simple relation between the portfolio value. But in this case, I'm doing it this way. So this is my beta prime VB with that the entire covariance matrix and the entire beta. You see, it's all framed, it's all used. And so I can convert that to systematic var using the normal model. I don't have to put the square root of time rule in here because I put it in the covariance matrix. And to multiply by 1 million to get the answer in dollars. Now, the equity part, you just partition the matrix and take the bit corresponding to the equity, and similarly for the beta, just the equity betas, and do the M mult that way. And again, you can just take the square root of the variance. It's already in H-day form. And for the foreign exchange, well, I could just have done it like taking this and that, but it's equivalent because there's no correlation in that case. But the result would be the same if I did the M mult between that and that. But because it's just a scalar, it didn't seem sensible to use M mult. Anyway, and so the sum of the vars here is 650096, which is greater than the systematic var. But if I changed all the correlations to 1, all of them, then you would have equality. Then the systematic var goes right up and it is the same as the sum of the vars. Sum of the vars doesn't change with the correlation. Well, it does change actually with the correlation between the equity. That will affect it. If I just undo it and now redo. So you can see that when I change that correlation, it does change the equity var, but it doesn't affect the foreign exchange var. And the foreign exchange var is not affected. That's the standalone var. It's the systematic var that is affected because there's only one foreign exchange risk factor here. So there we are. It's a spreadsheet that does very simple calculations, but there are so many different ways to do them. So that's the end of this video, and only one more to go for this topic.